session on the topic called light, shadows and... Done. Okay, so light, shadows and and now we are back with the next one. It's all about transparent, translucent and opaque object. Oh, screen is different. Sorry. Good morning, everyone. I hope everyone is doing well today, and we are back with our rapid recap session on the topic called light, shadows and reflection. And this is going to be a super simple session, and please have a notebook and a pen along with you so you can write down the important points, as we are going to discuss multiple points today. And not only that, if you find any kind of doubts in between, please feel free to post your doubts in the chat box or in the comment box so that I will be able to resolve it for you. And now we are getting into the session, and these are the main contexts that we will be discussing today, starting from rectilinear propagation, object types, shadow, pinhole camera, and finally reflection. So let me dive into the session directly, and you can see that Arun is here and the room looks so dark, right? Why? It's written already. No light in the room. That is what the reason the room looks so dark, right? What about Raju's room? You can see that the room is full of light and he is able to see all the things around him, right? Yes. So if you want to see something, there must be light. Am I right or not? Yes. So what is meant by light? That is the first question, right? Yes. So light is actually a form of energy that is very much required for the proper vision. Imagine that there is no light right inside the room. So what will happen? I will not be able to see anything right inside it, right? Yes. And now we are moving towards the very first topic. And before that, Arun has a small doubt. Oh, light travels straight or not? What do you think about it? Don't worry at all. Light always travel in straight lines. You have to be very, very clear about it. Light travels in straight lines. And what about this one? So when the light travels in a straight line, it has a very specific name. This is called rectilinear propagation. So light has a property of traveling in straight lines, and therefore this can be called it as rectilinear propagation. And what is the primary source of light that we have? It's nothing but the sun. So from the sun to the earth, the light is traveling in straight lines, right? Yes. But when you look at this activity, could you please let me know whether the person would be able to see the light or not? No way, because we know that light always travels in straight lines. In this case, we have a bent pipe and there is no way you can see the light here. Correct. So the person will not be able to see light at all. Got it? Now we are diving into the next one. That's all about the types of objects and luminous and non-luminous objects. There are mainly two types of objects. The luminous is nothing but the bodies that can emit its own light. So sun is a great example for it, that it can emit its own light. And when you talk about non-luminous body, moon is an example. How moon could be a non-luminous body? It doesn't emit its own light. That is what the reason moon is considered as a non-luminous one. Okay, so I hope you are clear with it. Sun can emit its own light, so it is a luminous one. Moon cannot emit its own light, therefore it is considered as a non-luminous one. What we are going to learn? It's all about the types of objects. So now we are going to segregate or categorize objects based on how light passes through it. Let me tell you, don't worry at all. It's a very, very simple and easy concept. And please don't forget to write down the notes. The first one is nothing but transparent. So glass is considered as a transparent object because it can make the light to pass through it completely. And that is what the reason, if you try to pour some water or a mango juice into a glass, you will be able to see it, right? Yes, that is what the reason behind it. And so when you talk about opaque objects, you can see that it doesn't allow any kind of light to pass through. And that is what the reason we call it as an opaque object. What about the next one? Translucent one. So translucent object is nothing but the object that allows light to pass through it partially. You might have seen the frosted glass. So frosted glass is an example for translucent object, that it is actually making the light to pass through it partially. So you can also take another example, that butter paper. So butter paper is also an example for translucent one. And that's all about the types of objects. And now we are diving into the next one. It's all about shadows. So you might have seen shadows a lot of times, right? Yes. So now we are going to learn how these shadows are formed. So when you look at it, you can see that there must be a light source, and this light source will be producing light, and this will be falling on the top of opaque objects, and these opaque objects are going to obstruct or block the light, and therefore it creates a shadow or a dark patch on a screen. So that's all about shadow. Now we are moving towards the pinhole cameras. The pinhole camera is very important, and you know that this is the most simplest camera. So this is a very simple camera. Okay, simple camera. And what about the image characteristics? Let's learn about how this pinhole camera has been made. It's a very simple setup that it consists of a cardboard box with a very tiny hole. Okay, so inside the cardboard box, there is a screen has been placed. What kind of screen it is? It is a translucent screen. Okay, so you have to write this point. It has a translucent screen. That's how the pinhole camera works. And pinhole camera, you can see that this is the object. So when you look at it, you can see that here is a pinhole camera setup. So in this, there is an object, and from the object, the light enters into the pinhole camera and it creates an inverted image on the screen. And what kind of screen it is? It's nothing but the translucent screen. So you have to be very clear about it. And now what we are going to learn is all about mirrors. So what are mirrors? So we need to learn about it. And you can see that Arun is actually looking into the mirror and he is able to see his image, right? Yes. And what kind of image it is? Can you please guess? Okay, let me break it down for you. So here, and Arun is actually looking into the mirror and he can see his image there. How is it possible? Is it possible? Yes, of course, because we all are familiar with plane mirrors, right? Yes. And what kind of image has been formed? Yes, it's nothing but erect image. Okay, this is an erect image. And what about other features? It is virtual, right? The image formed on a plane mirror is virtual. And what else? Same size, correct? It has a same size. And what else? Lateral inversion, correct. What is meant by lateral inversion? Can anybody tell me? Lateral inversion. Okay, that means if you raise your left hand, it shows us right. And if you raise your right hand, it shows us left. Okay, so you can say that erect, virtual, same size and laterally inverted. And not only that, the distance from mirror to the object and the mirror to the image is also going to be same. So you have to think about that too. And now we are going to learn about the types of mirrors. There are mainly two types of mirrors. The first one is plane mirror that we actually use on a daily basis. And what about the spherical ones? So if we talk about the spherical ones, there are mainly two. What are they? Concave and convex. So concave and convex. So these are the two types of spherical mirrors. So now we are diving into the next one. It's all about reflection. Very important point. So now we are going to learn about reflection in detail. It's very important to learn a few terms here. So before that, let me tell you the basic relationship between image formation and the reflection. So if an image has to be formed, there must be reflection happening. So now we are going to learn reflection in detail. For that, it's very important to talk about these rays. So this is nothing but the mirror. So let me write it down. This is the mirror. Okay, so this is a mirror, and now the ray that falls on the surface can be called it as incident ray. So please write it down, very important. So the ray that falls on the surface can be called it as incident ray. So this has to be given with this particular arrow, and we can name it as IR, incident ray. And the ray that touches at a particular point on the surface of the mirror can be called it as point of incidence, POI. This is a point of incidence. And from there, the ray returns back to the same medium as reflected ray. So this is the reflected ray that returns back to the same medium. Reflected ray. So RR. Okay. So now it's clear. And what about the imaginary line here? This is a dotted line that is represented here. And this is nothing but an imaginary line perpendicular to the surface. So this has a very special name, normal. So write it down. This is normal N. So the angle between incident ray and the normal is known as angle of incidence, AOI. Got it? Similarly, the angle between reflected ray and the normal can be called it as angle of reflection, AOR. Okay, so now all the terms are done. Got it? Yes. And now we are moving towards the types of reflection. There are two types of reflection. The first one is regular reflection. Second one is irregular reflection. Look at this. In case of regular reflection, what is happening? The surface is very smooth. So, the incident rays fall and the reflected rays are going to be parallel to each other. So, what happens? The image is going to be very sharp and clear. But when you talk about irregular reflection, the surface is rough. When the incident rays fall, the reflected rays are not going to be parallel to each other. Therefore, we get a blurry image. So, this is a basic difference between regular and irregular reflection. And now, we need to learn laws of reflection here. Whatever the type of reflection that you learn, it obeys laws of reflection. So, laws of reflection. Laws of reflection. So, laws of reflection has two statements. The first statement is nothing but angle of incidence is equal to angle of reflection. Angle of incidence and angle of reflection, both are equal. And what about the second statement? Very important. Incident ray, reflected ray and the normal at the point of incidence all lie in the same plane. So, you have to understand it really well that we are going to talk about incident ray, normal and the reflected ray. So, when you consider this, you have to say that this is the plane that we are talking about. Got it? So, incident ray, reflected ray and the normal all lie in the same vertical plane. That is what we are going to talk about in the second statement of laws of reflection. So, that's all about it and I hope everyone is clear with it. And now it's all about the summary. We discussed a lot of things today, starting from rectilinear motion, object types, shadow, pinhole camera and reflection. So these are the main topics that we discussed today and I hope everyone really liked it. And now we are moving towards the end of the session and that's all it for today. And let's see with an amazing session similar to this. Have a nice day and goodbye. Thank you. Have a good day, everyone.